So this one is ever so slightly obnoxious because it is tedious, but it isn't that hard, it's just time consuming. So this is implicit differentiation. And so we just kind of dive right in. The first part, there's nothing to it but to do it. 3x squared, nothing else to take the derivative of. But then y cubed is 3y squared y prime, not too bad. Then you have to use the product rule, so I'm going to go 6x times y as my split. So first times the derivative of the second plus the derivative of the first times the second. And then we just have to solve for y prime. So we have to collect all the y primes together. Let's put them all on the left. 3y squared y prime minus 6xy prime. And let's not forget we left this poor little 3x squared stranded, so bring him over. Okay, so far so good. Then I want to collect up the y primes. Okay, now I want to say y prime is equal to stuff over stuff. This feels very much like the process you go through when you're finding the inverse of a rational function, which is just a line over a line or something like that. And we see all those 3's and 6's. We don't like that. So we just squeeze them out. There you go. What is the slope of the tangent line at the point 3, 3? Well, that's actually easy. Y prime, and I'm just going to explicitly say x equals 3, y equals 3, is equal to 2 times 3 minus 3 squared. Nice that x and y are both 3 because you don't have to think too much about it. 6 minus 9 over 9 minus 6. That looks like a negative 1 to me. Negative 3 over 3 is negative 1. Okay, then it gets nasty, honestly. Okay, so at what point in quadrant 1, so I want the x and y values both, is the tangent line horizontal? Y prime is going to be 0. All right, but we know that the numerator here has to be 0 in order for y prime to be 0. And we know that y squared cannot equal to 2x. Okay, so presuming that we don't violate that condition, so let's say we have to say 2y minus x squared equals 0, but y squared minus 2x is not equal to 0. We need that to be satisfied. Right, Theodore? Yes. Okay, so then let's just solve for this. We get 2y equals x squared, or y equals x squared over 2. Great, but the problem is, this is telling us that, you know, along this curve, x squared over 2, somewhere along that curve, but we're not sure exactly why, then the tangent line is going to be horizontal. But that curve isn't everywhere. The curve is just somewhere, and wherever that curve is, we assume that it intersects this other condition somewhere. So this is what makes this problem a little bit annoying, really. Okay, so we have to then go back to this x cubed plus y cubed, which we got from the beginning, equals 6xy, and somehow use this condition in here and figure out what's going on. So that's the cool part, and that's the annoying part. The same, one and the same. Okay, so we're going to take every instance of y and replace it with x squared over 2. All right. Y cubed 6xy, and so we're ready to receive the y's, which are now x squared over 2's. Okay, so now it's just in terms of x, and so we just find the x, and then we find the y. Not too bad. And so let's see what this comes out as. X cubed plus... Okay, and then let's see, we have x squared, x squared, x squared, 3 of them, right? So 2 times 3 should be 6. But we also have 2 cubed, 2, 4, 8. So that's fine. And then we have 6x cubed over 2. There's way too many x's. So this is true if x equals 0. So definitely there's a point at the origin. So there's a point at the origin. We have this satisfied. Y prime is equal to 0 because this condition is satisfied. So at 0, 0, y prime is equal to 0, and we're also on this curve, but with this one little problem, is that it says in quadrant 1, but when you're actually at the origin, you're not in quadrant 1. So, but not in quadrant 1. Okay, so we keep looking. So it means since we don't have to worry about x being 0, we can factor out x on both sides as many times as we want. So let's get rid of x cubed. And so then you have the following. Pretty straightforward. Let's see, subtract 1 from each side. And multiply each side by 8. And you would think that we've done all this work that it would be a perfect cube, but unfortunately you'd be wrong. And it's going to be cube root of 16. Do we have to worry about negative cube root of 16? No. Only because the problem said in quadrant 1. If they said at what point is the tangent line horizontal, well, you know, we'd be collecting all three. But it just says quadrant 1. So we're going to keep pressing ahead. So we found the x value. And okay, we're going to look for the y value that goes with that now. We can go back to one of two places at this point. We can go back to the original function, or relation rather, or we can go back to this special condition. Either one of those works. If you plug your x in either place, you should get the same y back out. But this one's easier, so I'm going to say y equals x squared over 2, where x is the cube root of 16. And how does that help? Well, let's see. We're going to get 16 to the 2/3 over 2. I'm going to reduce this because I'm not happy with this. However, that being said, if you got this far, I'd be totally fine with that. But I feel compelled to do a little better than that. 16 is actually 2 times 2 times 2 times 2, right? And so I can take a set of 3 of them outside that radical symbol. And then I can say y is equal to 2 cube root of 2 squared over 2. And then I get 4 over 2. And then this 2 is to the power of 2/3. Well, what good does that do? Well, it's 4 times 4 to the 1/3. What good does that do? Well, a little bit of good. 2 times 3rd root of 4. So it just looks a little nicer. So the way I would write this point is 2 cube root of 2 cube root of 4. But if you choose to write it the other way, if you choose to write cube root of 16 and then 16 to the 2/3 all over 2, I'd say that is fine with me. Same. Okay? And then you should clap for yourself if you got that far. So seriously, take a blank piece of paper or print question 5 on the practice exam and see if you can redo it. And if you can arrive here, then you probably caught most of what I said.